All right, so we have a truss problem, and the requirements for the problem are just these four forces, not all the structures or all the members. And you can see that I've identified those with these little red squiggles. So this is going to be great for method of sections. I can make a cut right through this section, work one side or the other. I have 1, 2, 3 unknowns and 3 equations, so that's good. And then you can also notice that this element here, CG, as we talked about before, if you look at joint C, that classifies as what we call case 2. 3 elements connected, 2 are collinear, no load. So we know now that CG is what? 0 force member. So I'm just going to write immediately that CG equals 0, and I'll just write that I know it's that because it's a 0 force member. That's good enough for me. If it's correct, that's all you need to do. I'll just go ahead and put that there. Now I'll go ahead and with these elements, I'm going to go ahead and draw a line, and I'm going to now visualize whether I want to work the left side or the right side. There's not a tremendous advantage to either, but I think I will work the left side simply because there's fewer forces to account for, and my reaction at A, there's only one unknown. So that's what I'll do. So if I want my reaction at A, I'll go back and draw a free body diagram for the whole structure and just try to determine my reaction at A. So I'll go ahead and pencil in, or ink in, I guess better to say, that I do have a reaction AY, a reaction EY, and this is a pin, so this would also be EX. So I look at, if I do a free body diagram of the whole truss, and remember I'm trying to find AY because eventually I'm going to work this left-hand side. How can I find AY with one equation? Some moments where? At E. So I'm going to use right-hand rule for my sign convention, and I'm going to sum moments at E and make sure they're in equilibrium. So looking at the entire structure, summing moments at E, well, my reactions don't create any moment. This 500-pound force does not. And I've got 1, 2, 3 1-kip forces, and they all are a positive or negative moment about E. Positive. So I'm going to say positive 1 kip, and they have moment arms of 12 feet, 24 feet, and 36 feet. So I'm just going to sum those up. 12 feet, 24 feet, 36 feet. And then I got all the way over here to the end. There's my 500-pound, which is really half a kip. And it has a moment arm of 48 feet. And then I have my reaction AY, which creates negative moment also at 48 feet. So what is AY equal to? I believe it is 2. What does the equation say? Anybody can calculate that? That's 24. What do you guys get?
48.
42.
2.
2. You guys get 2 kips? I think it's 2 kips.
Yes, 2.
If we wrote 2 kips and just said based on symmetry, would you accept that if this was a...
No. Well, I don't know. If you write down 2 kips and it's right, I can't say you're wrong. But I have nothing. I may circle it and put a question mark by it. Where did this 2 kips come from? So I think it's always best. I think it's always best to show me what you're thinking. Because when you do make a mistake, I can see how serious an error is. If you just write down 2 kips and then it's wrong, let's say you wrote down 1 kip, everything you're going to do from now on is incorrect, even if you do it right. And I might be inclined to penalize you for that, for not showing your work. Okay, so now I'm going to draw the free body diagram for this particular structure. So give me a second to kind of sketch it out. I'm doing the left-hand side. And then I have my value for AY. It was positive, so it's acting up. There's my 2 kips. I have this half kip load acting down. At H, I have a 1 kip load. And then I'm going to assume tension forces in all my bars. So this will be the force in BC. Here's the force in BG. And here's my force in GH. I'm going to go ahead and look at the orientation or the angle of this member BG. So in the X direction, it's moving 12 feet. In the vertical direction, 16. I know that's hard to read. That's 16 and this is 12. So if you find the lowest common denominator, that's going to be a 4 to 3. That's our good old-fashioned 3, 4, 5 triangle. We like those. And I think that's everything else we need. I'll just go ahead and pencil in that this is B, this is H, this is A. So, method of sections allows us to write 3 equations. We have 3 unknowns, so now we're ready to go. Let's see if we can write 1 equation and 1 unknown. And then as we work our way through, let's try not to use any previous results in the current equation. Now, we've talked before in class, when we have all these groups of forces, one thing you want to find are points where they are concurrent. So where would there be points in space where our forces might be concurrent? Yeah. B is 1. And again, you look at the subscript, BC, BG, so B is going to be a good spot. And then someone said G. Even though G isn't on the body, if I did continue to look at the line of action of those forces, they would be concurrent at G. And also look at the subscripts, BG, GH. G's a good one. Any place else? I think that exhausts that avenue, right? Now, looking at the 3 forces, 1, 2, 3, they all have X components, right? So summing the forces in the X direction would probably not be a good idea, especially to start. But BG is unique in that it has a vertical component, right? So that would be another equation. So we're probably then going to sum moments at B, some moments at G, and then some forces in the Y direction. So let's do that. So using the right-hand rule, I'm going to first sum moments at B. Make sure we got 0. So looking at the way all these forces create moment about B, BC and BG does not create moment. What about our unknown GH? Positive or negative? Positive. And what's its moment arm?
16.
Yeah, it's the height of the truss, 16 feet. What about this 1 kip force? Well, it passes through B, no moment. But I have to worry about these 2. Worry is not the right word. I have to account for these 2. Try not to worry about anything. That's a good life thing to think about for outside of this course. A little philosophy there. All right, so let's account for the 1/2 first. Is that positive or negative about B? Positive. So I have 1/2 kips. What's the distance? 12. And then the 2 kip, positive or negative? Negative. And it's also 12. You could also take the composite of these 2 if you wanted to. You could turn this into 1 force that's just 1.5 vertically. Same result. So you should be able to solve for GH. It looks like it's going to be positive. This is 24 plus 6 is 18. What's 18 divided by 16? 1.125? Does that seem okay? Came out positive, so that means it's compression or tension? Tension. All right, so now let's go some moments about G. Now we'll talk for just for a second. Sometimes a lot of students find this very uncomfortable to be summing moments about some point not on the free body. But remember, the equation doesn't say anything about that. It just says some moments about a point. You can pick any point you want in space. Well, it's limited to 2 dimensions. But really, any point in space. So pick it to your advantage. And I'll be honest, a lot of problems, maybe ones that you might see on the exam, are rigged. Rigged's the wrong word. Have the advantage of their geometries when projected off into space. Forces are concurrent there. So look for it. Okay? There's a good hint for you. All right, so let's go about G then. So about G, these two forces, BG and GH, are concurrent. BC is going to create moment, positive or negative? Negative. So the force in BC and its moment arm is the height, which is 16 feet. And then I have to account for 1, 2, 3 of these forces. Let's start here. What about this 1 kip force at H? Positive or negative moment? Positive. And what's the moment arm? 12 feet. And then these two. Now they're both going to have the same moment arm, which is 24 feet. Let's start with the 1/2. Positive or negative moment? Positive. So 1/2 kip times 24 feet. And then the 2 kip force? Negative moment. Also 24 feet. A little more to account for. But we should be able to find BC. And I'm guessing BC should be in compression. Let's see. 48, 12, 36. What did you get?
Negative 1.5.
Is that right? I was trying to do the calculation in my head. I wasn't getting there very quickly. 24. Okay. Yeah, it's 24 divided by 16, right? All this comes out to be negative 24, and then divided by 16. That seems reasonable. Another thing to notice is that when I did this, I did not include a previous. I didn't have to worry about GH. So if you had miscalculated GH, it would not have affected your calculation for BC. They're not coupled. So from our original strategy, we said, what would be the last thing we could do? Well, at this point, you could do a couple of things. You could, some forces in the X direction if you wanted to, right? You would have BC and GH, you know those. Those are in the X. But that means that the values that you just computed would contribute to this, which means it could propagate an error. So I think a much safer way, if it works out for you, is to try to write an equation that's independent of the other. So in this case, that would be summing the forces in the Y direction. Because BG is the only one of the unknowns with a Y component. So what is the Y component of BG? It looks like it's 4/5. Is it positive or negative? Negative. So we got 4/5 of the force in BG. And then we've got, let's account for all of our other forces. We've got a 1 kip down. We've got a 1/2 kip down. We have a 2 kip acting up. So what is the force in BG? 0.625? I'm guessing. I don't know. I have no idea. I just guessed. 1.8? That doesn't sound right.
0.625.
Yeah, 0.625. I think that's right. Because all this adds up to 1/2, right? And then you would multiply by 5, divide by 4. 0.625. And I think that would come out positive. Now let's go back and just check our intuition. With a truss in this configuration with loads basically acting down in gravity, we would expect the bottom cord to be in tension. We have a HG. HG came out in tension. Great. We'd expect the top cord to be in compression. So BC should be in compression. What about these guys? The diagonals. I don't know. That's where when we talked about it before with the diagonals going one to orientation, it was this way. I never can remember that. I'm just going to have to go with my equation. My equation says it's in tension. So I don't feel too bad about this problem. If I got this problem on the exam, I would think I got this one. I don't know about you guys. That's what I would think. Any other questions about this? Okay.